Now, as we are done with the introduction, let's move on to some abstract concepts on how to actually store passwords in a database. Now, what happened back in the days was when some company registered their users onto their website, they used to store the information of all the registered users, which are basically the usernames, passwords, emails, first names, last names, into their database in plain text. Now, the database server needed some kind of login or had some kind of security measures for anyone to access, but only the higher guys in the hierarchy knew that. So the network administrators, the database administrators only used to know the password. So there was some kind of security, yes, but the problem was what happened in some kind of insider attack. So what an insider attack means, that some guy in the company, within the company, is the attacker. So what happens if some guy went rogue? He could actually hack the password by using some social engineering techniques, or the network administrator himself could be a hacker, who knows. So he just knows the password to the database server. So when he logs into the database server, he could see all the information within the database lying around in plain text, which is visible through naked eyes. So now one guy had access to millions of users' emails, passwords, their names, and their social security numbers. So anything could happen, right? So that was a major security breach. So to get over the security problem, they used to encrypt the passwords and then keep it to the database. So what happened in encryption was the password, which was in plain text, was converted to some altered text, which was actually accessible through a key. So which means the key was used to alter the text from the plain text, and that key could be used to get the plain text back from the altered text. So in the language of cryptography, that altered text is also called a ciphertext. So this is kind of secure, right? So anybody, if there was an insider attack, anybody could dump the password database and he can take that in his home, and when he logs into the database, all he would see is a chunk of random text which is meaningless lying in the database, which doesn't have any meaning. So is this secure? Well, not exactly, because when you learn about cryptography or when you learn about encryption, you would know that the encryption needs a key, and the key is not the password that the user gave, because what we are using is we are taking the user's password and we are encrypting the password. The password is not encrypting any other thing. If you are a little bit lost, you can just listen again what I just said. So if I recap, the password is encrypted itself. So what is the key that we use to encrypt the password? So there is some kind of key, right? So that key is kept somewhere in the database in some other table, or the password or the key is hard-coded into the project code. It's possible. So what happens if the same guy or the same rogue insider attacker also has access to the codes or to all the tables in the database? So what could have happened is he would dump both the tables or both the database and the source code. Now he can search the source code for the key. He could just read all the text or find the important parts where the key might have been used, and that key can be used to decrypt all the information in the database, which is not in plain text, which has ciphertext, right? So this is also a security breach. Now you can see from this image that encrypted password has some kind of IVs. So IV is basically an initialization vector. So what initialization vector does is, the initialization vector is a random value that is XORed in some kind of way depending on the algorithm, but let's just say that the initialization vector or the random value actually alters the ciphertext in a way that for same two values the ciphertext would not come same. So that's why IVs are used, but let's not talk about details of IVs. So what am I trying to tell here is that encrypted passwords can also be broken down if the network administrator or the rogue insider guy has the access to all of the tables in a database or the codes. So he can just simply grab the IV or initialization vector and the key, and he could just simply decrypt the key. So there is something to hide, which is the password in this case, and the way the password can be decrypted back to the plain text is also lying somewhere in some other tables or the code itself. So that is also not very good. That's why in the recent days we use something called hashing. So we will talk about what hashing is, but let's just say when we use hashing, it's a very interesting concept because the password actually is never stored in the database. So if you're asking then how users would authenticate themselves, let me say, when the passwords used to be encrypted, what we did was when we log in a website, we give the password and hit enter. That password is going to flow through the wires to the server. Now that password is stored in a variable, and then the encrypted password which is in the database is decrypted back with the key which is hidden in somewhere to the plain text again. So if the plain text version of the password and the password that the user has just typed in matches, then the user is authenticated, right? So that is not used in hashing. So what hash does it? The database stored some kind of strings which represents the password, but not the password or not the encrypted version of the password at all. And when the user types in the password and hits enter, even then the password is not sent over the wire or never leaves the computer. The same conversion happens within the computer itself. So that hash value which the user did in his computer goes through the wire, and if those two values match, that is the one which the database has and the one which the user just made, if those two hashes match, then the user is authenticated. So in this way, the password is never sent through or never stored in the database. So if some hacker hacks the database or hacks the connection between the two endpoints, then even the hacker could not know what the password is. Now you can see from this image that if their hashing is used, we could use salts. Now salts is some kind of thing which I am going to explain in the later videos, but let's just say salt is more like an IV, which is some random value which is needed to alter the plain text version of the password in some way. So again, salt is basically a randomizer like IV. So what happens if even the hacker has the access to the salts and the database, even then the password he cannot break it out because the password was never stored at all. So hashing is the mechanism that is used currently to authenticate users.